Good evening. Can everyone see the screen?
Yes.
Okay. So last class we talked about variable and primitive type. So we know each variable will have can store data with a type and a name. And we learned about 5 primitive type. Which include int for integer or whole number. And we'll have double for the decimal number. We have string for the text, char for the single character, and we have bool for the true false data. And I see people asking, or for those who have some experience in coding, you might learn like another type called flow. Flow is another data type for decimal. Now the difference between double and flow is they will require different memory space. So when you are taking probably 211, you will learn the difference between them. Right. So for now, we will just focus on this 5 data type, and we will use double for the decimal number in our class. Okay, and C++ name rule. So when we give a variable a name, we can only choose letter digits and with the exception underscore. So normally, since we are not allowed to have like a space in the name, and if you want to break the words, we can use underscore. And we must begin with a letter. Now, if you want to start with an underscore, I think C++ will also accept that. You won't run into an error, but normally we will start with a letter. You can start with a digit, and you can have any other symbol. Any questions here? Okay, so to declare the variable, right, before we use the variable, we must declare it. So to declare a variable, we will always have a type, right, wherever the data type you have here. So you will have the type followed by whatever name you want to call the variable. Right, so this is how we will declare the variable. And we learned how we can input a data from the screen to the variable. So we will do cin, we'll have the right arrow, and then we will have the variable name for whatever where we want to store the data. So at the end of the last class, I give you like an exercise. So you want to have a program that will ask user's name, and you want to say hello to the name. Right, so not everyone is here when we did the exercise. So here's the code for what we did last time. So we will have standard beginning. Right, so this part is always the same. And you have the standard ending. Right, so we'll have the standard beginning, and then we'll end it with return 0 close bracket. Now, in between the standard beginning and ending is where we put our code. Okay, any questions here?
No.
Okay, now we need to ask the user for the name, right? So before we use it, we need to declare a variable name so we can store the data. So we will have string name, right? Since name will be a string type. And before we ask the user, but before we take in the data, we should have a prompt, ask the user to give the name, right? Otherwise, the user won't know you are asking for their name, right? So before you ask something, but before you want to, you want an input, you should always ask for it. So this is what we call the prompt. When you want an input, you must ask for it, right? Otherwise, the user won't know to input you the data. So once you ask this, right, you print out what's your name, the user will know you asked to, you will ask the user to input some data so you can take in whoever the data to name, and then we can print out hello with a space and then followed by whatever the name is giving, and then we can have cout inline. Now I see people asking, can we have these three in the same line? So this three line can be combined with cout, and then we can print hello with the space followed by the name, and then we want to end the line. Right, so the reason here is this three line, they all have the same instruction. If you look at this three line, they all have the cout instruction. So a shortcut in C++, you can output many things with one instruction. Right, so since most of the programmers are lazy, because later on you'll be a programmer, you will be doing hundreds, thousands of the line. So there will be a lot of shortcut there. So if you are constantly using the same instruction, most of the time there will be a way you can do it all at once. Okay, so if you look at it here, so instead of have cout three times, you can just have one instruction for these three things you want to print. Same thing for the cin. If you have multiple data coming from the user, you can also do it in the same line. As long as there is no other instruction in between. Or declaring the variable are the same thing. If you want to declare multiple variable with the same data type, you can also declare all at once. Okay, so let me pull out the code and then run the code for you. Let's see. I should have it as the example one. So we will compile it. Okay, so it asks what's your name. So here I will put my name, and then it will say hello to my name, right? Because that's what we ask it to do. Now let me run the code again. And now let's say instead of have my name, my first name, I will just input my full name, my first and last name. And then when I run it, what happened here? It only say hello still to my first name. So what happened here is when you ask the user for the input, every time when you hit a space, it will count as a separate data. So when C++ read it, your first name is a data, right? It's a string data, and your last name will be a data. So when you input your first name and last name here, the cin name will only take in your first name and then it will move on, since it only asks to store the first data you input. So it will only store the name and then move on, say hello, and then in the name it store your first name, and then it will end the line, finish the program. So your last name, the second data, never get read in from your program. So that's why when you write your program, you need to be very precise on why you're asking for the user. So let's say you want to ask that you want the user to give their full name, first and last name, and you will say hello to their first and last name. Then instead of just a name, you need to have two variables. Right? So you need to have a variable store their first name, and you also need to have a variable to store its last name. So instead of doing string first and then semicolon for the first name and then string last semicolon for the last name, since both variable here is a string type, so I can do a shortcut, put them in the same line. So I have string and then my first variable, comma, the second variable, and then you can do as many as you want, and then you will end the line with a semicolon. So the semicolon is always at the end of the line. So now you declaring the two variables, they both string type, and then you will ask what's your name. Now here I will say, what's your, let me do it like this. What's your full name, right? So you will know to do the first and last name. And then when we input the data, we will ask to print first. We will first store the first name and then the last name, because that's normally how people type in their name. And then we will want to say hello to the name. So instead of just print out the name, we want to print out the first name and then the last name. Is there any problem here? Okay, I see people say space. Good call. So if you just say first and then followed by last, when you print hello, you have hello space, and then your first name, you will have your first name get printed, and then you will have the last name right after with no space in between, because you did not ask for it. So if you want a space in between your first and last name to make it look nice, you need to make C++ do it. So C++ won't do it for you. You need to do everything yourself. Okay, so let me just save the code here and then run it for you.
Professor?
Yes.
Where do we declare the type of the variable?
At the beginning.
Oh, okay.
Right, do you see we have string before? We have string and then we have first, comma, last.
Yeah, I see.
So all your variable here will be declared as the string type. So here I have my first and last name here, right? First name space, last name. So the space will pretty much tell C++, here is the data, and then after the space, there's a second data. And since we did not put a space in between, your first and last name, there's no space in between. So to fix that, you need to add a space in between the first and last. So you will just so you have like a quotation with a space there. So you will print the space, and then you will have your last name. Okay, so we compile and then run it. Ask you for your full name. And now I run it, there's a space between the first and last name. Okay, so are we all good here?
Professor, can you show us how you did it again? Just the work. I want to see how it was done.
On the code.
Yeah, on the code.
So if you just want to quickly see your code, you can just do the cat, and then with your file name, and it will show you your code without going into the file, and then you need to use exit, right? So here is the standard beginning, and we declare two variables at the same time. And since they are both string type, if you declare a variable with different type, then you need to start with a new line, right? You would need to do one first, and then you will start with the data type, and then the variable name, and then the semicolon. If they belongs to the same data type, you can do it in the same line. Good?
1 second. Yes, it's good now. Thank you.
I see people say, why does not need to add space in input? Okay, so for the input, we don't need to add space because in the input, whenever you have a space, the C++ will like the space is like an indicator for it's a new data. So every time you hit a space, it will treat it as like a separate data. So when we read this string type, it don't read the space. So if you look at it, the first and last name get stored into the different variable, right? Since when I type my first space and last name, here is my first string data, and you have the space, and then the second, you will have your second string data. So when it gets stored, you have cin first. So wherever the first data will go into the first, and then it will keep reading from the input. So the last name will get stored to the last. So pretty much here, what you are doing is cin first, and you will do cin last. So you will do the instruction cin twice. And since it's the same instruction, I just do a shortcut, make it into the same line. Good? Okay. So today's class, we will learn how can we change the value of a numerical variable. And we will learn assignment operator and some arithmetic operators. Okay. So we learn how we can declare a variable. Right, so every variable is like a box in the computer memory. Right, so let's say here I have a box called X, so we can declare as int X. Let's say I want to store an integer. Now, right now, when you do that, this box have no data assigned to it. So let's say you want to assign it a data. Let's say you want X to store a 5. Then you can have X equals to 5. So this equal sign is like the assignment. We can change a variable like the following. So you will have the variable name always on the left-hand side, and then you will set that equals to whatever thing or whatever data you want to put in. And you will end there with a semicolon. So this equal here, this equal sign here is the assignment operator. It's a little different than just the equal sign. Means whether the value on the left-hand side equals to the right-hand side. It's a little bit different than that. So this it's not really an equal sign, it's just an assignment operator. You will assign whatever that data in the right-hand side to the variable. So this will tell C++ to change a variable to the thing. So for example, if later I don't want X to be 5, I want to change it to, let's say 7. I can just say X equals 7. So originally X have 5 in it. Now you want to change it to 7, then you just have X equal to 7. So it will kind of get rid of the 5 and then replace it with the 7. Now you can also do something more complex. You can have X equals to 1 plus 2 plus 3 plus 4, and then let's say minus 12. If you do that, what do you say X equals to?
Two.
Is it 2?
Or is it -2?
-2.
Mm-hmm.
Right, so you have 1 plus 2 plus 3 plus 4, that will give you 10, minus 12 give you -2. So what it does, it will erase the 7 and then assign it with -2. So this equal sign here in C++, it's pronounced, or we'll read it as is made equals to. This means X is made it, or is made equals to -2. Now you see that we can do some calculation, or we can do some arithmetic in it. So now I will show you some arithmetic. So we are familiar with addition. Subtraction and multiplication, right? So you know the add, subtract, multiply. Now I let x equals to 2 times 3 plus 1. What will x equal to? X will get updated to 7. Right, again, this is the same x we used before, right? It's the integer data, but we declare x as an integer. So keep that in mind. So if I let x equals to 1 plus 2 times 4, what does it equal to? What will x get updated to now?
9.
Do we all agree with 9? No one say 12? Okay, so the answer is 9. So the way C++ does is just like how we calculate the arithmetic. So we have 1 plus 2 times 4. When we have addition and multiplication, we will do multiplication first. So 2 times 4 give you 8, and then plus 1 will give you 9. So when we do arithmetic in C++, the precedent or the order we do the arithmetic is the same as in math. Which also follows PEMDAS. And I see people mention that in the chat. And what's PEMDAS stands for? I don't know, did everyone know PEMDAS?
Parenthesis, exponent, multiplication, division, addition, and subtraction.
Okay, I see people also put it in the chat. So P is the parenthesis. So whenever you have parentheses, it will override all other operations. You will always go for the parentheses first. And then normally you will have exponent next if there is exponent. And you will go with multiplication, division before addition and subtraction. Right, so this just means multiplication and addition, multiplication and division will go before addition and subtraction. Now I see people asking, can you declare a value from the start? Yes, so that's what we call initialize your variable. So instead of just declare like an empty box and then put in a value later, you can just have your data type, your variable name, and then you can just assign it with whatever things you want to do. So you can have it all in a line and then finish with a semicolon. So normally C++ will read line by line and then within the same line, left to right. Okay, so I won't write out what does PANDAS mean since people already put in it in the chat. So now if I let x equals to 1 plus 2 times 4, what will x become? So that will be 12, right? Since you have the parenthesis override the multiplication. Now notice that I didn't mention division here. So division gets some kind of special treatment in C++. So I'm doing it after the addition, subtraction, and multiplication. So division were written as slashed, as what we expected. Now, if I have x equals to 6 over 2, what will the x value get updated to? 3. Now, if I let x equals to 10 over 3, what will x become?
Three.
Okay, so I see most people still say 3. Any other answer? Okay, so I see people say 3.3333. Okay, remember what primitive type is x?
Integer.
Is an integer, right? So we declare x as an integer, which means you cannot store anything besides integer. So since we set this integer x, variable x, equals to 10 over 3, it can only store the integer. So what C++ does is it will just take the quotient part of your division, right? Remember when you first learned division, maybe in 2nd grade or 3rd grade, before you learning decimal number, how do you learn divide? And I see people say long division, right? So the teacher probably say, oh, you have 10 apples, and then you try, you're trying to give it to 3 people. So what do? You will give each person 3 apples, and then there will be 1 left over. Right. So we will do it. We will do this as 3 goes into 10 3 times with a remainder 1. So your so the x will just take the quotient part. You will take this part as your answer. Now here is now a rule you need to be aware in C++. When you divide two integers, you will get an integer answer. Okay, and then let me
Professor, does int follow the same rounding rules?
oh no. So the C++ is not smart enough to do one thing. So it's not like if we do 10 over, let's say we do 5 over 2. Right. So 5 over 2, it will have 2.5. So for 2.5, we normally round it to 3. But what C++ does, it will only take the quotient part. So I suppose say, so it always run down. Yes. So for quotient, it means when you divide, you always run down. So when we do the integer division, you will get the quotient. And there is, I suppose say, so 3.1 run to 3. We don't really call it rounding because I don't want it to confuse you. So what we really does is the integer division, it will give you the quotient when you divide the number. Now the quotient part of the integer division is normally when you divide the number, then run the number down. If that makes sense to you. Now we talk about addition, subtraction, multiplication, and division. And there is another operation. If you see earlier, I put here the percent sign. So this is the modular operation. What it does is it will give you the remainder. So it will give you this part, 1. So if you do 10 mod 3, that will give you 1. So this is pronounced as modulo, and sometimes in shorthand we will just call it mod. So most of people will just call it 10 mod 3. So the mod will give you the remainder. Okay. So the operation percent sign is just x modulo y. This means the remainder when you take x divided by y. Any questions here?
No.
Okay. Now let me give you a summary of the arithmetic rule. So when we combine, okay, so if you remember earlier, we said when you divide 2 integers, you will get an integer answer back. Now here, it not only works for divides, it also works for when you combine any 2 integers. And by combine, we mean any operation. So when we combine 2 integer type value, or if you do operation with any 2 integer type, you will give you an integer result. And when you combine anything else, it will give you a double answer or a double result. So here is the example. So if you have 10.0, but 10.0 will be a double type over 3.0. What will C++ give you?
3.
Another double.
Right, so we have a double divided by a double, so you should get a double type back. So the C++ will give you 3.333. Right, so I believe C++ probably give you 3 decimal, 3 or 5 decimal. Now, if you have 24 over 10.0, what do you expect getting it? So you will get 2.4.
A double answer.
It will also be double answer since you have an integer over a double type. Right, so if you look at the rule here, only combining 2 integer will give you an integer back. Anything else will be a double answer. So if you miss with integer and double, it will give you a double. So if you have 5.0 over 2, you will get 2.5. Okay, now let's make it more complex. If you have 4 plus 20 over 10.0. Okay, I see people say 2.4. Okay, now if you have 4 plus 24.0 over 10. Is it 2.8? I see people say so I see people say 6.4 and 2.8. So we have 4 plus 20.0 over 10. So when we have addition and division, division will go first. So we will do 24.0 over 10 first, which will give us 2.4, and then add the 4, that will give us 6.4. Now let me give you the last one. And I will say this is the most tricky one. What's 4.0 plus 24 over 10? So the answer will be 6.0. The reason here is we have addition and division. Division will go first. And 24 over 10, instead of 2.4, it will give us 2. Since 24 over 10 is an integer over integer, combining 2 integer give you an integer back. So this part will give you a 2. And then when we add a 2 with 4.0, it will be a double. So your answer will be 6.0. So this 6.0 will be a double, but when you print it, it probably, when you print a double with the 0.0, I don't think C++ will print the 0.0 for you. It will probably just print the 6 for you, but it will be a double. So we just write that 6.0. Any questions here?
Nope.
Okay, and let me run the let me make an example here, and then we can test it in our program. So let me make a file called example.cpp. We'll have standard beginning, include IO string. I would say by now everyone should have the standard heading memorized. Okay, so let's see. Okay, so let me see out. So just print the data out so you will know what kind of data you will print. So we can have 10.0 over 3.0. We'll end the line. See out 24 over 10.0. And then we have 5.0 over 2. Then we have 4 plus 20 over 10.0. And then we have 4. I see people asking, why do I put space in between divide? You don't need it. I just put it so it looks better. So everything is not crunched together. It's just like a style or for the readability. If you don't have the space, it's fine. C++ don't really care about the space or the indentation. There are some language where indentation is important, like Python. If you messed up the indentation, you will run into error. But for C++ and I think also Java, it doesn't care about the space and the indentation. But it's just for the readability. So people read your code, it's just easier to read. Okay, I think that's the 6th example we have, and then we have standard ending. We'll have return 0, and then end the bracket. So let me save it, compile it, and run it. Okay, so we have on 3.33333, we have 2.4, we have 2.5, we have 2.4 for this one, and then I have 6.4, and then here we have 6. And the reason we have 6 here instead of 6.0 is just for the dex, for the double. I think if your decimal is 0.0, you just ignore it for you. But this is the double type. Let me check something here. So let's say we store it as, like an integer. Let's see what it works. So let's say I let x equals to this number. It should store as a double, so I believe it should give you error message. But it might automatically cast it into integer. So let's try it out. Oh. So it still work. Let me try it. Okay. So if you look at it here, so what happened here is if you didn't use the correct data type to store your calculation here, so what happened here is if you use the integer, it will still do the calculation for you, but since at the end your variable can only store the integer type, so what it will do is it will kind of convert your decimal number, right, your double type, into an integer. So by doing so, you will miss or you will lose the decimal part. So if you look at it here, right, if you look at our code, right here, I let x equals to 4 plus 40.0 over 10. So this should equal to 6.4 if we have a decimal type. But now, since we only have an integer variable to store this double result, so what C++ does is it kind of just convert the double type into an integer. So by doing so, you lost some part of your data, which it lost the decimal part.
Professor, would it be safer then if you were doing mathematical calculations where you weren't sure that everything was an integer to just declare everything as a double instead?
You could do that. So let me see, if I change this to double, I think it will still print 6. Let me see. So it really depends on what you want to do. So if you want to do a calculation, if you know you are doing some division, which will result into like a decimal result, then you might want to declare as like a double. Unless you know you are doing that, you will always stick with the integer variable, right? Since for people doing like number theory, they pretty much just deal with the integer. So they will only need to use the integer type. Even with the division, because they only care about the quotient, then the integer division work perfect for them. Okay, so let me change it to double. Okay, so if you look at it now, I declare this as a double. I still have a 6 here, but the 6 here is really a double. So since you have the 0.0, it kind of just ignore it for you, even when you have the double type. Now, one thing you need to be aware of, even when you declare a variable, let me mute someone. Okay. So even when you declare a variable as a double, if you want to divide two integer and then get a double result, you should always change one variable into into like a double type. Because if you do calculation in between the integer, you will get a result of integer type. Even you declare the variable as a double type. Right, if you look at here, if you look at our last example here, I declare x as the double type. So x is double. But when we do the calculation, we have 24/10, which both of them are integer. So when you do integer over integer, you still get an integer result. It's just part of your arithmetic. So you'll get 2 here, and then you add the 4, and you will get 6 as a double, as a decimal number. Instead of here, you will get 6.4. So just be aware of that. Any questions here? Okay. And let me just show you another exercise. And I pre-code some exercise here. Let me show you the code before I run it. Okay. So if you look at it, right, so I have x to be integer 24, y to be 5, and then I have dx representing the double version of x and then the double version of y. So I have 24.0 and 5.0. And I have ounce representing the answer and then the d ounce for the double type of the answer. So when we have 24/5, we have an integer over integer. Right, so we will expect the answer to be integer. So so it will first ask us what's our answer, and it will print the correct answer. So what's 24/5? Okay, so it's 4. So if we check our answer, it will give us 4. Right, so 24/5 will give us 4. Next question is 24 modulo 5. So modulo is the operation that will calculate the remainder for us. So what's the remainder when you take 24 divided by 5? It's also 4. Right, it's 4 again. Right, so you will have 4. Now the next question, so we have the double version of 2.4 divided by 5.0. So what's the answer? It will be 4.8. So if we check it, we have 4.8. And then the last question, we have the integer version of 24 over the decimal version of 5.0. So our result should be a double. Right, so we will save it in the d ounce. And it will print it. It will see, we have CL, and then we will print the correct answer. So we will expect the same thing, 4.8, since we have integer over a double. So if you look at it, it will give us a double answer. Okay, so we will end our class here. If there's anything with the arithmetic you are not sure with, you can always put it into the program and then test it, especially when you have arithmetic mixed with the integer and then the double. So if you're not sure, you can just print it out, see out whatever operation you have, let it calculate it for you. And then from the experiment, you should be able to see what's going on there. Okay, and just a reminder, I think starting from tomorrow till next Wednesday is the holiday, so we don't have any class. So the next time we will gonna meet is next Thursday, right? So the September 9th, a week from today. So so next Monday, Tuesday, Wednesday, we don't have class.
Have a good
Okay.
night.
Have a good day.
Take care, Professor.
You too.